Hello everyone, welcome back to our channel gsipucmysuru. MYSURU. Today we will begin with the fourth chapter of our first PUC electronics syllabus, that is passive electronic components. So in this chapter we are going to mainly focus on the three different types of passive electronic components, that is resistor, capacitor as well as inductors. So let us begin with the very first session of this chapter. So the electronic components are broadly classified into two types. So what are these electronic components? There are a number of electronic components like resistors, capacitors, inductors, diodes, transistors, IGBT, MOSFETs, LED. Like this, there are a number of electronic components, and these electronic components are broadly classified into two types. So electronic components are broadly classified into two types. One is the passive electronic component, the other one is the active electronic component. So let us first try to understand the difference between passive electronic components and the active electronic components. Passive electronic components are those components which absorb or which store or which dissipate energy. They do not have energy by its own, or they do not provide energy to the network. That is, they are not able to supply energy to the network. Network in the sense, it is nothing but a circuit which contains source and different components, a number of components which are interconnected together to form a closed loop. So these passive electronic components, they absorb the energy what is being delivered by the source, and they store that energy as well as they are going to dissipate energy. So there are three types of passive electronic components. One is the resistor, second one is the inductor, and the last is a capacitor. So what these passive electronic components do? They absorb energy, they store energy, and they dissipate energy. So what is this absorb energy and helidre? In our second chapter, that is principles of electricity, we have seen that whenever a source and the resistors are connected, whatever the voltage we are going to apply with the help of the source, that will be dropped or that will be consumed by the resistors. If I am going to consider a simple example, this is a voltage source and I am having a single resistor. So let us consider this as the V and this as the resistor R. So whatever the voltage I am applying with the help of this voltage source, that voltage will be dropped across this resistor. So if I am going to apply 10 volts, and all of the 10 volts will be dropped across this resistance R. If I am going to consider that I am having two number of resistors, let me call this as R1 and this as R2. So whatever the voltage I am providing or whatever the voltage I am supplying with the help of the voltage source, that will be absorbed by these two sources, or these two resistors, that is R1 and R2. But technically we are going to tell that the voltage will be dropped across R1 and R2. So the passive components will absorb the energy. The passive components, that is the resistor, will absorb the energy. And the second one is it stores the energy or stores the energy and ಹೇಳಿದ್ರೆ, coming to this inductor and capacitors, the energy will be stored either in the form of electrostatic energy or in the form of magnetic energy. That we are going to deal with when we look into these topics, that is inductors and capacitors. And dissipate energy and ಹೇಳಿದಾಗ, these passive components will dissipate the energy. Some amount of the energy will be wasted in the form of heat. That is what is called as the dissipation of energy. So these passive components absorb, store or dissipate energy, and they do not supply energy to the network. So passive components are the resistors, inductors as well as capacitors. Coming to this active components, these active components will amplify the circuit, rectify the signal and change energy from one form to another. They are going to amplify, they are going to rectify, and they are going to change energy from one form to another. And the examples for these passive components are op-amp, transistors, diodes, semiconductor diodes irbodu athwa zener diode. There are a number of different types of diodes. Zener diode, LED is also one of the type of diode. So these are some of the examples which comes under the category what is called as the active components. So these active components are nothing but the components which are having the capability to amplify, rectify and change the energy from one form to another form. What do you mean by this word amplify? Amplify anta helidre it strengthens the weak signal. Suppose I want a voltage of 10 volts anta tilkoona at the output side, but at the input side I am having only 1 volt. So what I am going to do is I am going to build a circuit what is called as an amplifier which strengthens that 1 volts to 10 volts depending upon the gain of that amplifier circuit. We are going to study in detail about this amplifier in a second year PUC. Coming to this rectifier. Rectifier is nothing but the process of converting AC to DC. Whatever the supply we are getting through the electricity board, that is pure AC. But some of the appliances like that can be our mobile phone or a computer. So there are a number of electronic devices or the electronic goods what we are going to use in our daily life requires DC. So what we are going to do is we are going to use a separate circuit called as a rectifier which converts that AC and gives us DC. So the rectification or the rectifying job is done with the help of the diode, and the amplifier job is done either with the help of a op-amp or with the help of a transistor. Coming to the last term, that is it changes energy from one form to another. If I am going to take an example of this LED, LED is nothing but a light emitting diode. So what does this LED does? LED converts the electrical energy into light energy. So these are some of the examples for the active component which amplify, which rectify and changes energy from one form to another. So these electronic components are broadly classified into two types, that is the passive components and the active components. Passive components will absorb or store or dissipate energy. Examples: resistors, inductor as well as the capacitor. And the active components are the component which has the ability to rectify the signal, amplify the signal and change energy from one form to another form. So only the passive components cannot be used in any of the circuit. Along with the passive components we have to use these active components. In this chapter we are going to mainly focus on these three types of passive components, that is resistor, inductor and the capacitor. Now let us try to study in detail about this resistor. So what exactly is this resistor? Resistor is nothing but a component which limits the flow of current. So its job is to limit the flow of current. And resistor is nothing but a passive component which is used in the circuit which offers a specified value of resistance. So what exactly is this resistor? Resistor is nothing but the component, or it is nothing but a physical component what we are going to use. And what is this resistance? Resistance is nothing but the property of the resistor to oppose the flow of current. The resistance of this resistor is not affected by the direction of flow of current. The symbol for the resistor is this. It is not affected by the direction of flow of current anta helidre. It behaves in a same manner whether I am going to give a AC across this resistor or I am going to give a DC. That is, the property or the resistance offered by this resistor is same for AC as well as DC. And the unit for this resistance is ohm. Symbolically it is represented like this, ohm, and the resistor is pictorially represented in this, and the resistor will be denoted by the capital letter R. So resistor is nothing but the physical passive component which is used in the circuit which offers the specified value of resistance. So what exactly is this resistance? Resistance is the property of the resistor which opposes the flow of current, and the unit to measure resistance is ohm, which is denoted by this symbol, and the resistor is denoted by the capital letter R, and the resistance of the component is not affected by the direction of current, that is its behavior is same for both AC as well as DC. AC is the alternating current and DC is nothing but the direct current. So this resistor behaves in the same way for both AC as well as DC. Now let us see some of the applications of this resistor. Some of the major applications of this resistor is it limits the flow of current, limits the flow of current, it divides the voltage, and the third, it is used to protect the circuit, protect the circuit elements, and the last major application is it dissipates energy. So the resistors are used to limit the flow of current, divide the voltage, used to protect the circuit elements, and dissipate energy. So what is this limits the flow of current? Suppose I am having a voltage source, then here I am having a single resistor. So this is a voltage source, this is a resistor. So this voltage source, as soon as this voltage source is turned on, then the current starts flowing in the circuit and that current flows through this resistor. So limits the flow of current ಅಂತ ಹೇಳಿದಾಗ, if I am going to consider a single resistor whose value is, let me think it as R. So the current which flows through this resistor will be limited. If a wire is not having any kind of resistor ಅಂತ ಹೇಳಿದ್ರೆ, the current can easily flow over them. So here I am not having any kind of resistor, that is R is equal to 0 here. So resistor is not present in any of the branch or in any of the circuit ಅಂತ ಹೇಳಿದ್ರೆ, the current can easily flow because there is no one component which is trying to oppose the flow of current. But in the same circuit, if I am going to include a resistor which is having some specified value, then this resistor will try to oppose the flow of current. So it limits the flow of current andre this resistor will try to limit the flow of current or it try to oppose the flow of current. Coming to this second application, it is used to divide the voltage. As I have already explained you, the voltage source whatever I am connected across the resistor and the voltage what I am going to apply with the help of voltage source will be completely dropped across this resistor R. Suppose I am using another resistor. If I am going to consider this as R1 and here I am connecting another resistor R2 and again I am connecting another resistor R3 anta tilkoಣ. Then whatever the voltage I am applying with the help of this voltage source will be dropped across all these three resistors R1, R2 and R3. If the resistance values are same, if all the resistance values are same, I am not talking in terms of numericals, I am talking in terms of just resistance value, that is R antane tilkoಣ. If all the resistance values are same, then the voltage what I am applying with the help of a voltage source will be divided equally among all the resistors. But if the resistance values are different, then the voltage value or the voltage whatever I am applying with the help of a voltage source will be divided across all these three resistors in a different way. Suppose I am applying a voltage of 10 volts anta ankoಳ್ಳೋಣ, then the voltage here might get dropped to 3 volts, here it might get dropped to 4 volts, then here also it might get dropped to 3 volts. That is R2 and R3 values might be same. Suppose this is equal to 2, the voltage dropped across 2, that is the voltage drop across the resistor R1 is 2 anta ankondre, 3 plus 2 gives me 5 and the remaining 5 volts have to be dropped across this resistor R2. So, the sum of all these voltage drops must be equal to the voltage whatever I am applying with the help of a voltage source. So, the voltage will be divided. So, these resistors are used to divide the voltage. So, the third major application is it is used to protect the circuit elements. In almost all of the electronic circuits, we are going to use these resistors as one of the major. Coming to this third major application, that is it is used to protect the circuit elements. In almost all of the electronic circuits, these passive components, that is these resistors, are most widely used because it helps in protecting the circuit. How it protects the circuit? It limits the flow of current. If there is any flow of heavy currents in the circuit, these resistors will try to oppose the flow of current. By this way, it will protect the overall apparatus. Coming to the last one, that is it dissipates energy. Some of the energy will always be lost. That is, some of the energy and ಹೇಳಿದಾಗ when I am going to consider this voltage source, all of the 10 volts will not be dropped across these 3 resistors. Some of the energy will be lost in the circuit in the form of heat energy. So, these resistors will help in dissipating the heat into the surroundings. So, these are some of the major applications of the resistors, that is it limits the flow of current, it divides the voltage, used to protect the circuit elements, and it dissipates the energy. Now, let us see some of the specifications of these resistors. So, in the specifications of these resistors, the very first specification is the ohms rating. So, what is this ohms rating? Ohms rating is nothing but the maximum amount of resistance offered by the resistor is called as ohms rating. So, that is maximum resistance offered by a resistor when it is used in circuit, when it is used in the circuit. So, if I am going to consider any single resistor whose value is equal to 1 kilo ohm, so that resistor is having a resistance value, maximum resistance value of 1 kilo ohm. So, ohms rating will be different for different kinds of resistor, and the size of these resistor will also vary depending upon the resistance offered by that resistor. So, ohms rating is nothing but the resistance offered by the resistor when it is used in the circuit. Coming to the next specification, it is the power rating. It is the ability of the resistor to dissipate energy in a safe manner. It is the ability of resistor to dissipate energy safely. So, I told you that these resistors will dissipate energy in the form of heat. But we are having a power relation P is equal to I square into R. Here P is directly proportional to I square, that is P is directly proportional to current. So, the power rating will entirely depend upon the current flow. Whenever there is increase in the current, or whenever the current flowing through the resistor has increased to a larger extent, then that resistor will not be able to withstand that higher current. So, that resistor will be burned out. So, that resistor will be burned out in the sense that resistor cannot be used further in the same circuit. So, every resistor will be having some power rating. If the power rating is increased or that power rating is directly proportional to current, so this current value, maximum current, will be fixed for each and every resistor. If that maximum current has crossed, then the resistor will not be able to withstand such higher current, which in turn burns out that particular resistor. So, what exactly is this power rating? It is the ability of the resistor to dissipate energy safely. That is, to dissipate energy safely in the sense without getting damage. So that is the second specification. Coming to the third specification, that is the tolerance. So this tolerance is nothing but the percentage variation in the resistance value with respect to its marked value. So it is the percentage variation in its resistance value with respect to its marked value, respect to its marked value. We have studied about this tolerance in the first experiment of our lab, that is color coding of resistors. Color coding of resistors contains either 4 bands or the 5 bands. If I am going to consider a 4 band resistor, then the 4th band will be the tolerance band. So this tolerance band is the percentage variation. Suppose when I am going to consider the same example of a resistor which is having a resistance of 1 kilo ohm, 1 kilo ohm resistance. This 1 kilo ohm is nothing but 1000 ohm. So it is having a percentage variation of, or it is having a tolerance of plus or minus 5%. Then the 5% of this 1000 is 50. Then the resistance value might range from 1000 minus 50, that is 950 ohms, to 1000 plus 50, that is 1050 ohms. So the resistance value which is marked as 1 kilo ohm, when it is used in the circuit, that resistance value might vary from 950 ohms to 1050 ohms. So that is what is the meaning of this tolerance, that is percentage variation in its resistance value with respect to its marked value. Whatever the resistance is marked, accordingly there will be a tolerance value of each and every resistor, depending upon which its value will either increase or decrease. So tolerance is the percentage variation, and that percentage variation will lie from plus or minus 1% to plus or minus 20%, as we have already seen in the color coding table of the resistor. The next specification of this resistor is temperature coefficient. Temperature coefficient tells us how the resistance value will vary with the temperature. In conductors, the resistance of the resistor will increase with the temperature. But in semiconductor, the resistance of the resistor will decrease with increase in temperature. So this temperature coefficient can be defined as alpha equals RT minus R0 divided by R0 into T, where RT is the resistance at T degrees centigrade, RT is the resistance at T degrees centigrade, and R0 is resistance at 0 degrees centigrade, and T is the temperature. So the temperature coefficient alpha may be defined as increase in the resistance at T degree centigrade to its resistance at 0 degree centigrade. So that is nothing but increased value of the resistance from 0 degree to T degree is measured in terms of temperature coefficient, which is given by RT minus R0 divided by R0 into T, where RT is nothing but resistance at T degree centigrade in ohms, and R0 is the resistance at 0 degree centigrade in ohms, whereas T is nothing but the temperature. Now let us solve one simple problem on this temperature coefficient. So this is the problem what is given. The resistance of a coil made of copper wire is 100 ohm at 0 degree centigrade or 0 degree Celsius. So at 0 degree the resistance of the resistor is 100 ohm anta helidre, that is equal to R0, which is equal to 100 ohm. Calculate its resistance at 30 degree centigrade. calculate its resistance at 30 degree ಅಂತ ಹೇಳಿದ್ರೆ that is nothing but the temperature. So T is equal to 30 degree and you have to calculate the resistance at 30 degree. In the sense you have to calculate RT for the given value of alpha, which is equal to 0.004 per degree centigrade. Now we are having this formula alpha equals RT minus R0 divided by R0 into T, where you have to find out what is called as RT. Alpha value is 0.004 equals RT minus R0 value is 100 divided by 100 into 30. So 0.004 into 30 into 100 gives us 3000, which is equal to RT minus 100. So RT equals 3000 into 0.04 gives us 12. This 100 comes to the left hand side, but this 100 is having a minus symbol. Then when it is taken from the other side, it will become positive, plus 100. So RT value is 100 plus 12, which is equal to 112, and the unit for resistance is ohms. So this is how you can calculate the given problem for the temperature coefficient. So in this session we saw what are the two different categories of electronic components, or how these electronic components are broadly classified. They are broadly classified into passive component and the active components, and we saw the difference between the passive as well as the active components. We saw some of the examples of active components as well as the passive component, and we started with the very first passive component, resistor. We saw the definition of resistor, applications of resistor, and some of the specifications of resistor. In my next session I will be continuing with the same topic. Until then, take care. Bye bye.